Hi, I'm Michael Huang, and this is the SensorPro board that I worked on last FTC season on Team 9048 Filobots. So, I made this board for a few reasons. First of all, the FTC rules only allow LEGO certified sensors to be connected directly to the NXT brick. However, there are a lot of advantages to using smart sensors like the InvenSense MPU6050, a gyro sensor, over using a more expensive and less powerful HT gyroscope. Also, the number of sensors teams use is limited because there are only 4 ports on the NXT, and 2 of those already go to motors or servos, usually leaving the robot with at most 2 sensors during autonomous. In order to solve these problems, teams have tried using the HT SuperPro prototyping board to add more sensors, but the SuperPro has a lot of limitations. For example, it only has analog and digital pins, and no advanced communication ports like I2C. So you still can't attach smart sensors like the MPU6050 or even LEGO certified sensors that use I2C. So in order to solve this problem once and for all, I created a new approach. This approach includes adding a secondary microprocessor, an Arduino Nano, to continuously aggregate data from sensors it's connected to. Then the digital pins on the SuperPro prototyping board B0 through B7 become a parallel bus enabling data transfer between the Arduino and the NXT at 1 byte at a time. Then the read pin on the SuperPro board is wired to the Arduino interrupt to signal a read request to the Arduino. Finally, when the NXT requests data from the sensors, it sends a read request. The Arduino then supplies data through the parallel bus in an interrupt handler. More details about this process can be found in the white paper that I attached as a text document in my submission. So, after I come up with this concept, I designed a PCB in Eagle, and I was fortunate enough to get it manufactured for free by Advanced Circuits, who I had convinced to sponsor my team. After the board arrived, I soldered on the components and uploaded the Arduino sketch which I had programmed earlier. Again, there are a lot more details to this process in the white paper that I uploaded. So the next few videos are of the functional end product. Okay, so what we're doing here is we're trying to see if using the gyro will help us with our turning during autonomous. So when we turn 90 degrees to the left, the motor should stop. So here the robot is using the board to get data from the sonar sensor and the gyro sensor to determine the goal position and move straight as well as turning accurately. As you can see, the SensorPro board solved the initial problems and allowed my team to use advanced sensors during last year's autonomous. A major future vision I have for this project would be to create a generic board that other FTC teams would be able to use. However, since next year's FTC control system is drastically changing, I would have to do more research into next year's control components. Regardless, the basic concept of aggregating sensor data on a hub separate from the main robot controller may still be a valuable idea worth exploring.